Okay, in this video I'm going to be going over how to acquire the large river polygon data for input into RVD and RCA. Um, First step, I usually just Google National Map and go to this TNM download version 1.0. It's the one I prefer to use. Unfortunately, it's being maintained right now, so imagery is down. But anyways, the first step would be to zoom to your watershed of interest. You can see all these Huck 8 boundaries right here. I have no idea where I'm at, but the process is the same. You select hydrography over here, NHD. You select best resolution. It's usually defaulted on this. You're going to select Huck 8 subbasin, and then you can choose a geodatabase or a shapefile. I prefer shapefile because if you choose the geodatabase, you have to export the shapefile out of the geodatabase to be able to use it for RVD and RCA. So it's best to just use it as a shapefile. You'll hit Find Products. And I actually do know where we're at here, so I will zoom to the basin. Basically, as you can see, there's 7 pages of data that you can download. So the more zoomed in on the basin of interest, the less data there's going to be there. So it's a little easier to find. So say I'm concerned about the Toucanon. That's where I need a large river polygon for. I know it's this one just because the shape of the boundary, so I'll zoom into that. I'll return to search, find products again. It's going to reprocess based on my area. And you can hit this footprint and it'll show you what you're downloading. So, or you can look at the shape here. So, if I'm working on the Toucanon, that's the one I want. I will download that. Extract it to where I want it. Alright, so now to finish processing this, we'll go into ARC. So here's that folder. They'll just call it shape. So if you have multiples of these, you do need to create a folder and name it whatever your watershed is, or just put this within your watershed folder you're working in. And the piece we're after is this NHD area. So if I pull that in, it's a large river polygon for that watershed. So just to give you a picture, I'll bring in the NHD for this area. So as you can see, it's a little overextensive. So one of the first steps we need to do is clip it down. So I will just clip it to the Huck 8 boundary. Select the boundary, search for the clip tool. We're going to input what we want clipped, clip it by the Huck 8. You got to make sure if you're using the whole Huck dataset that you select the actual Huck 8 so it only clips it to that. And I actually didn't worry about saving this as anything meaningful yet because I'm pretty sure I'll still have to reproject it because it usually comes not projected. And it looks like we might have to edit a little bit this little segment here and probably this here. Sometimes the NHD area is overextensive and where we just want areas where there's a thick band of EVT classified as open water, that's where we want the large river polygon. If there's some open water cells and it's not like a connected band, you don't need to worry about it. So I'm working the toucan, and let's see, we want our land fire. So I'm just going to go into the land fire attribute table. I'm going to scroll to open water, and I'm going to select those cells. So as you can see, this is the main stem snake, and it's just a thick band of open water cells. So if we didn't use a large river polygon here, the tool would actually classify these open water cells as riparian. And the reason we classify open water cells as riparian is because of these smaller streams. Like these are 30 meter pixels, where this stream is only maybe 10 meters across. And so saying that this cell is open water and not riparian, it might be a little bit inaccurate. So this is the best way we found to capture that. So I mean, if I leave this part of the polygon there without editing it out, it's going to classify that as open water and basically throw that cell out, or any of these within the polygon. But I don't want that, because I do want them classified as riparian, because you can zoom in here on Google Earth and you can see this is a really small stream, and to throw out a pixel because it's in a larger polygon that's classifying it as open water is probably not the best thing to do. So basically, where you determine where you want an actual large river polygon is based on stream size and what you see on the EVT. So where I'm not seeing a thick band of cells through here, I don't want a large river polygon for this portion. You can see this here. So this isn't as huge as the snake, but there is a continuous band of multiple pixels wide. This stream you would want a large river polygon for. This one, it's a little more sporadic. I wouldn't use one there. And you can go into Google Earth and measure the stream's distance. So we're dealing with 30 meter data. You don't want to use large river polygons definitely on any streams that are less than 30 meters. So if they're greater than 30 meters wide, you should question whether or not to use one. So now that I know where I actually need the polygon, I'm going to start editing that NHD area that I clipped. I definitely don't want this section, so I'm just going to come in and clip that, or cut that, and delete. Little segment there, delete it. And I definitely don't want that. Delete. Save edits, stop editing. I'm going to go into the properties, go to source, and as I thought, it is only in a geographic coordinate system, so we still need to project it so that we can use that as an input. So that will be the final step here. We'll go to project, and you make sure you're doing project data management and not define projection. This tool does not work. So we'll input our clipped, specify where we want it saved, and then we've just been keeping it as an NHD area just for consistency, an NHD underscore area, and since it's going to be in a project folder with its watershed, we know where it's going to be. It's just like an input that we don't really need to mess with too much, so we don't have a fancy naming protocol for it. Save that wherever it makes sense for you, and make sure the output coordinate system is in line with all the other data for that area. So Tucannon I know is 11 north. So you'll project it. And if we go check that out, bring it in, and I'll just bring in the original just to show the difference. So the original is this overextensive, unprojected data set that just has a geographic coordinate system, and our final is only within the boundary of our watershed. It's projected, and we've gotten rid of portions that were included that we didn't want included. So, and now that's ready to be used as an input to RVD and RCA.